to all the participants, we will start in a few minutes, just waiting a bit for others to come in. Steve, I believe we can start if you are ready.
Okay, so hello. I know we have people attending from all over the world, and depending on your time zone, I wish you a very good morning, afternoon or evening, and thank you for joining what promises to be a very content-rich and engaging webinar on sustainability and an introduction to the work being undertaken by the International Commission on Large Dams. My name's Stephen Usher, and I'll be moderating the webinar today. I'm the Deputy Editor and ESG Manager at Aquamedia International, the publisher of the International Journal on Hydropower and Dams. I have a particularly strong interest in sustainability issues, having previously worked as the Environmental and Social Programme Coordinator for the Nam Turn 2 project in Laos, and separately for the United Nations on sustainability projects throughout Asia and Latin America. I've also served on the ICOLD technical committees for environment and climate change. Sustainability is certainly one of the most important topics affecting the public perception and support, or indeed the opposition, for dam construction worldwide. And many news stories and articles in the general media focus on the environmental and social aspects of large infrastructure, and ultimately these perceptions can lead to the approval or cancellation of schemes. As this slide shows, the programme today will introduce eight areas of discussion to help unwrap some of the key issues relating to sustainability and identify opportunities to ensure dam infrastructure continues to play a crucial role in the green energy transition, as well as to help mitigate some of the principal challenges from climate change, including droughts, flooding, and water supply. And we're very fortunate to have leading experts sharing their knowledge, both within the dam engineering profession, but also more broadly from other industries too. And I'll be introducing each of these speakers shortly. Just before I do that, I'd like to mention a few housekeeping messages. Firstly, we hope and expect the webinar to be fully interactive, and we encourage anyone with questions to use the Q&A facility within Teams, which I hope you can each see at the top of your toolbar towards the top of your screens. When doing so, if you could please type your questions in, and include the name of the speaker who the question or query is directed to, and also your own name and affiliation, if any, to ICOLD. The format of the session is such that your speakers will each deliver their PowerPoint presentations, and we expect these in total to last about an hour and a half or so, with the Q&A period to then follow towards the end of the webinar, once all the speakers are finished. However, if you have a query or a question as the speakers are progressing, please feel free to post it at any time. You don't need to wait for the Q&A session. As I say, towards the end of the session, depending on how much time we have left, we'll try and squeeze in as many questions as possible, and we'll read these out and direct them to the speaker you've addressed them to. Excellent. Right, so without further ado, let me introduce the first speaker today. Michel Lino is co-founder of ISL Engineering, with 40 years of professional activity dedicated to the engineering of hydraulic infrastructure. He is now a consultant in the field of dams and hydropower and a member of several expert panels on dam safety. He served as ICOLD Vice President between 2016 and 2019 and as President of the French Committee on Dams and Reservoirs until last year. In 2022, he was elected President of the International Commission on Large Dams. So, Michel, if you could be so kind as to start sharing your screen, thank you.
Thank you very much, Steve. Yes, I'm sharing my screen. Dear colleagues and friends, it's my pleasure and honor to say some words to introduce the first webinar on dam and sustainability. Sustainability is a core value for ICOLD in line with its mission statement. ICOLD mission is to lead the profession in setting standards and guidelines to ensure the dams are built and operated safely, efficiently, economically, and are environmentally sustainable and socially equitable. This mission is emphasized in the ICOLD Code of Conduct, which require to act taking account of the social, ecological, economic responsibilities, is Article 2, and to limit the use of non-renewable resources, help to reduce adverse impact on the environment, and encourage the use of renewable energy resources, Article 7. I mentioned that ICOLD is currently preparing a World Declaration on the role of dams in the energy transition and climate change adaptation. The initiative was launched by the ICOLD board in June 2023 at the General Assembly of ICOLD in Gothenburg. The Technical Committee T on Prospective and New Challenges for Dams and Reservoirs in the 21st Century, chaired by Deroo, is leading the process in collaboration with other relevant technical committees. Technical Committee D on Concrete Dam, chaired by Conrad, Swiss. Technical Committee E on Embankment, chaired by Jean-Pierre Tournier, Canada. Committee F on Engineering Activities for Water Resources Projects, chaired by Eric Alpin, USA. Committee J on Environment, chaired by Peter Amos, New Zealand. Technical Committee G on Sedimentation and of Reservoirs, with Christian Howell as chairman. Technical Committee P on Cemented Material Dams, chaired by Dr. Jia, China. Technical Committee Y on Climate Change, chaired by Denis Albrecht, France. Technical Committee LE on Levy, Rémi Tourmont. Also, the Young Professional Forum is involved in the initiative and possibly others. I'm very pleased of the level of interest in the Dam and Sustainability initiative within ICOLD. I hope that the entire dam community will commit to changing our practices to ensure the sustainability of our existing and future dams. On behalf of the ICOLD board, I would like to thank the organizers of this first webinar and all those who have taken the lead in this initiative, and also all the participants connected today. So thank you very much and have a very nice webinar. Thank you.
Thank you very much, Michel, for those opening remarks and welcome. Next to speak, let me just put up this one. Next to speak, we have Luc Deroo and Francisco Ortega, who have both been instrumental in the organisation of this webinar and ICOLD's increasing focus on sustainability. And as such, they now present an overview of the proposed work that remains ahead.
Thank you very much, Michel, for this introduction, which sets the bar. Thanks to Steve for agreeing to moderate this session. We would now like to explain what this seminar is all about before opening the floor to the presentations and to your questions. This introduction will be given by myself, Luc Deroo, and by Francisco Ortega. As Michel said, ICOLD launched these initiatives, and Committee T has been tasked with leading it and liaising with all other interested ICOLD committees. We understand that there are two aspects to this. The first task is to continue to raise awareness in our dam community to ensure that all our projects include sustainability as a primary objective. The second is to better understand what this means, to, as far as possible, put facts and figures to this concept. We know that this is a very broad subject, a subject that has already been investigated by many others, a subject that is already being discussed by ICOLD in its technical community. So we recognize that we have yet to define what needs to be done and how it needs to be done to fulfill the mandate. That's why we thought it would be appropriate to start with a series of webinars as a support to discussions. The first webinar takes place today. We plan to hold 3 more. Webinar 2 would be dedicated to LCA, life cycle assessment. Webinar 3 to greenhouse gases accounting, and webinar 4 to accounting for other factors. We look forward to receiving your thoughts and proposals on our work program. At this stage, it's all very flexible.
Thank you, Luc. I step in now. Good day to all of you. Also from my side, I am Francisco Ortega. I would like to introduce the purpose and motivation for this first webinar. In first place, we would like to disseminate the general concepts of sustainability among the members of ICOLD and to raise awareness of the need to design, build, and operate dams more sustainably. It is important that we can attract the interest of as many as you as possible from the various technical committees and to receive useful and practical feedbacks and comments during and after the webinar. And we'd like to remark that this webinar is not about lecturing by experts. It is about establishing a framework for the scope and format of future work that we need to develop among the members of the technical committees and hopefully assisted also by external experts. These are the 6 presentations, as Steve presented before, that we have scheduled for today. The first one is about the general framework of the Sustainable Development Goals that have been established by the United Nations in 2015. And I will go through the various SDGs, trying to classify them in relation with the effects and benefits of dams, and mentioning also how ICOLD is aligned along the different technical committees with these SDGs. I will provide some graphic at the end indicators of the urgency to act. ICOLD Technical Committee G on the Environment was formed in 1972 and deals with many environmental issues related to dams and reservoirs, including socioeconomic and ecological aspects, their effects and benefits. And beyond GHG emissions, we must integrate this extensive experience into the assessment of the sustainability of dams. Technical Committee D is currently working on evaluating on the sustainability of concrete dams. We will learn what has been done and what is planned for the near future in this context, including life cycle assessment of concrete dams, as well as thoughts on decommissioning, recycling, and circularity. We strongly believe that the analysis and methodologies carried out by TCD could well anticipate an example to be followed by other technical committees of ICOLD. And I pass now on to Luke again.
Thank you. And the next presentation will focus on LCA, life cycle assessment. Please, LCA uses standardized methods, which is very important as standardization can provide a shared and trustworthy framework. Webinar 2, the next webinar, will elaborate on LCA and on how it can be applied to dams. Today, we thought it would be good to have a general introduction, and this will be given by Joachim Verdier. Then, next please. Then, thinking in terms of sustainability is a shift from a purely commercial or financial assessment to a broader assessment. A broader assessment in space, including the people and systems affected by the project, a broader assessment in time, including lasting effects. This shift to broader evaluation has been initiated by economists decades ago. It is therefore very useful to understand how they proceed, how they integrate externalities, and how they take long-term effects into account. This presentation will be given by Lamis Aljounaidi, an economist specializing in infrastructures. And eventually, the last presentation is an attempt to put some fences between what we should address and what would remain outside of scope. An attempt to set a reasonable ambition, to define a perimeter, and to suggest metrics. All of this, of course, will be open to discussion today and in future webinars. Thank you.
Thank you very much, Luke and Francisco. I should mention Luc Deroo, of course, is Chief Technical Officer at ISL, and ISL and Luke and Francisco have been instrumental in the organisation and the logistics of this webinar. And without the work behind the scenes of ISL, we wouldn't be here today. So thank you very much for that. There certainly seems to be a huge amount still ahead to do for ICOLD committees, which of course is one of the reasons for the webinar, to bring together key members from the different committees as well as outside experts. We'll now move on to looking a bit more in depth at some of the issues raised, starting with sustainability frameworks and the sustainability goals of the United Nations framework. And taking us through that will be Francisco. Francisco is an international specialist in the design and construction of concrete dams with more than 35 years of experience. Since 1999, he's been running consulting engineers company based in Germany, and he's member of the Spanish and German national committees on large dams, where he represents these two countries in the ICOLD Technical Committee P, dealing with cemented material dams. In addition to this, he's leading the preparation of the second volume on the sustainability of concrete dams with Technical Committee D, which we'll hear a bit more about later as well. So over to you, please, Francisco. Thank you.
Okay, thank you, Steve. Let's start with the general overview of the SDGs as a main framework to our work. The World Commission on Environment and Development gave in 1987 an inspired and now classic definition of sustainable development as the development which meets the needs of the present without compromising the ability of future generations to meet their own needs. And at this point, we must emphasize that sustainability is not just about protecting the environment, it is also about ensuring stable social and economic growth for all. Sustainable development is therefore often seen as resting on three main pillars that interact with each other: the environmental, the social, and the economic pillar. For each of these, a brief explanation is given to the right of the figure. Our development objectives during the first half of the last century were probably almost entirely dominated by the goal of economic prosperity. Since the late 60s, growing awareness of the environmental impact of our production system has led us progressively towards a more sustainable balance. However, there is still a long way to go to achieve a real balance between the three pillars, which is represented at the intersection area in the center of the figure. The path to this end could be defined as sustainable development. For those less familiar with the SDG framework, it consists of 17 goals, which in turn are oriented towards 169 targets that are measured by a set of specific indicators. In the link and QR code on the right below, you have direct access to a detailed explanation on the United Nations website. Using the example of our dam design, construction, and operation business, we will review the SDGs by classifying them according to their impact and benefits. Starting with the SDGs on which dams have a clear positive effect, number 7, which is about clean water and sanitation. Sorry, number 6. Number 7 is about clean energy based on hydropower generation, and number 8, promoting economic growth. It is clear that dams have positive spillover effects related to goals number 1 and number 2, which aim to eradicate poverty and hunger, as well as SDG 9, which deals with building resilient and sustainable infrastructure and fostering innovation, or Goal 11 on supporting cities and communities for sustainability. With some other SDGs for which dams may have, at least at some point in time, some kind of benefit. This is the case for at least goals 3, 10, 16, and 17, I believe. But there are clearly others for which mitigation measures are required to reduce the impact of dams. This is the case, for example, in the social aspects of sustainability, which relate to the respect of local communities, resettlement, or justice and reduction of inequalities in water use between regions and countries. As per SDG 16, all this requires strong institutions and effective sustainability policies. Rounding out this quick review of the SDGs is the impact of dams on the environment, which is clearly focused in 3 of them. Number 14 and 15, due to the effect on aquatic and terrestrial biodiversity traditionally included in environmental impact studies, and number 13, which calls for reducing the impact of our economic activities in climate change. And in our case, it is asking us, for example, to reduce the GHG emissions in the design, construction, and operation of dams and reservoirs. Let's dive a little deeper into ICOLD and the principles of sustainability. For those of you who are not familiar with it, this short document is an absolute statement of sustainability principles. It was made by ICOLD almost 30 years ago. We highly recommend reading it. It is available on the ICOLD website, and this code provides access to it. The updated consideration of sustainability goals based on the UN scheme can be seen in relation to the scope of the different technical committees of ICOLD. Committee T has been mandated to take this initiative forward, but this task involves many other committees dealing with, for example, environmental aspects, committees on the environment, sedimentation, or climate change. Social issues which are dealt with in committees such as public safety, public awareness, resettlement, gender diversity and inclusion, and logically, with those committees that deal in general with the planning, financing, and evaluation of dams and reservoirs, without forgetting the necessary incorporation of the younger generations that will take over from us to continue this task. Finally, the committees that I mark here in yellow and that are most directly involved in the technical aspects of dam, concrete, embankment, cemented material dams committees, and so on, should be the generators of specific studies to improve the sustainability of the different types of dams that each of them deals with. And why all this effort? Luckily, it seems that our societies in general have now admitted climate change. This was not so widely accepted only a few years ago. I would like to show an obvious fact, the relationship between GHG emissions and global warming. The graph represents the evolution of CO2 concentration in the atmosphere over the last 800,000 years, based on measurements in air trapped in Antarctic ice. As can be seen, this value has always varied naturally between 180 and 280 parts per million, except at the last moment, as can be appreciated at the end of the graph, when it suddenly rises to 420 ppm. Zooming in on the last 1,000 years, in which the CO2 concentration varies little around 280 ppm, one can clearly distinguish the increase of this value on the far right of the graph. During the last 120 years, corresponding with the industrialized era. After 1958, the same values are also obtained from in situ air measurements. The figure shows now the graph of global average temperatures in relation to the period 1951 to 1980. The upward trajectory since then took a current average difference of plus 1.5 degrees Celsius leaves no room for doubt. Of course, the GHG effect is necessary to sustain life on the planet, but the huge alteration of recent times is warming the planet due to an excessive GHG effect. And you can see both curves drawn up on top of each other. Global warming is one of several indicators. Some of them already exceed the scientifically recommended limits for sustainable life on the planet, as represented in the graph of planetary environmental boundaries. Based on this graph, sustainability economists have developed a more ambitious one that includes social aspects represented in the center of the so-called donut economics. It includes the 9 planetary boundaries and 12 social SDGs. The red extension above the ceiling and below the base indicate boundaries that have already been exceeded. And between social and planetary boundaries lies an environmentally safe and socially just space in which humanity can thrive. I would not like to end my presentation without underlining the importance of intercultural understanding to enhance sustainability. ICOLD is a global organization where this important value is highlighted and experienced among members and in our work in the technical committees. Our vision is that the United Nations Sustainable Development Goals framework and the existing structure of ICOLD offer an excellent opportunity to enhance dams and sustainability. And thank you very much.
Thank you very much, Paco, for those slides, that presentation. It's certainly very evident, the increase in carbon dioxide and the temperature increases. That reference to donut economics, a book by Kate Raworth, a professor at Oxford University, is well worth a read. I actually have it on my desk.
Actually, yes, actually, you're right, yeah.
Yeah. So now we move slightly beyond greenhouse gases to other key parameters within the environment. And to guide us through that area is Peter Amos. Peter is Managing Director of Dam Watch Engineering Limited, a specialist dam engineering consultancy based in New Zealand. Peter is a dam engineer with 35 years experience in dams throughout their life cycle, and he's led teams of engineers, environmental scientists and social experts throughout the development phase, integrating engineering with environmental and social mitigations. He's also been the national representative on ICOLD Committee for Environment for several years and is the current president of that committee. So over to you, please, Peter. Thank you.
Thanks, Steve, for the introduction, and greetings, everybody, from Environment Committee, Committee G. I've been asked to discuss with you the social and ecological aspects, aside from the GHD component, which Paco has been talking about just before. So today I'm just hoping to summarise the current situation from the environmental and social side, and that includes the water storage gap that we face, talk about the challenges that we all face in obtaining and maintaining the social licence to operate, and some of the environmental and social aspects that support sustainability initiatives and what we can do to address those. Paco's already shown you a nice slide of the 3 pillars that support sustainability, and as he was saying before, it's where these 3 pillars come together that we see successful sustainable development outcomes. So the situation, well, we all know that water storage is becoming more important because we're facing population growth, renewable energy demand increases, and of course the climate change. But we're also facing all these challenges in a world which is more politically volatile. There is changing regulatory frameworks occurring, and we have a community which is far more environmentally aware than they were many years ago. Public expectations also are far stronger about the quality and standard of the infrastructure that's being delivered for them. But if we look back at some of the existing dams and the reservoirs that we're now managing, many of the environmental impacts that were created during the development of those assets are baked in and are now causing problems with the ongoing operation. We have stakeholder grievances that have been passed down from generation to generation, and they won't abate. And it's some poor examples such as these which are causing problems and resistant to development today. In regards to the water storage gap, we know that global water storage is diminishing. There's quite a bit of factual evidence on that from the World Bank and others. With sedimentation of reservoirs, ageing dams, the lack of maintenance, inefficient operation, these are all compounding to reduce the total volume of water stored. We also face diminishing water quality, and the environmental degradation we're seeing is impacting the aquatic species. We can address the water storage gap, but it will be a challenge. We need to consider water storage as a system, not as an individual asset. We need to be making better use of the existing storages through rehabilitation, reoperation and retrofitting. And we need to think about alternatives like off-river storage to reduce the sedimentation risk, converting single-purpose reservoirs to multi-purpose, using other forms of water storage like wetlands, groundwater recharge and so on to supplement the dams and reservoirs that we are operating today. And in this development of reservoirs, we need to be focused on mitigating the environmental and social effects. We have some tools for that, of course. Well-known fish passage, managing environmental discharge so that it improves the health of the river systems, buffer zones around reservoirs, and on the social side, developing sustainable food sources and providing economic opportunities for the communities that surround these reservoirs. If we can resolve some of those outstanding social issues from the previous reservoir development, such as resettlement, then we'll move societal expectations a long way towards greater sustainability. For new water resource development, of course, it's really important that we can deliver balanced needs and options assessments, and it's balanced across all of the environmental and social safeguards. Again, we need to be identifying the environmental and social effects and putting forward mitigations to the community and stakeholders. It's really important to involve these specialist environmental advisors and social advisors at the early project design stage, not after the project has been commissioned. It's important to be consulting with the affected stakeholders, and that could include local NGOs, to seek support from them. Because we're trying to demonstrate a significant degree of public acceptance with all our key decisions, that they are supporters of the environmental initiatives and social initiatives that we're bringing to our developments. Because if we can gain the community support, then it's much in favour for the project owner's interests. We all know that the general public is much more informed than they once were. They're using the internet to research any issue in detail, and they've used their social media channels to solicit support for the various issues that affect them. So if we are mounting a local stakeholder consultation initiatives, then we'll provide a measure of the real needs and impacts, and therefore the ongoing costs that relate to these projects. We need a social license to operate our dams and reservoirs, and this requires engagement with a wide range of stakeholders, including the community involved, ordinary citizens, Indigenous people, ethnic minorities, women, disadvantaged other individuals, and alongside that with lobby groups, NGOs, regulators, and other government stakeholders. The engagement needs to use technical presentations, town halls, public hearings, direct consultation with the stakeholders, because you need to bring to them evidence of the baseline condition and offer mitigations and demonstrate how those mitigations will address the issues that the stakeholders see. It's really important to provide feedback channels so that stakeholders can see that their concerns are being addressed and that the design reflects the issues they raise. The objective really is a negotiated outcome, because that will be more successful in the long term, because stakeholders will have a degree of ownership of the outcomes, and then we'll see reduced long-term costs for the project owner, a smooth path to licensing, and an ability to amend and alter the project going forward. So to address sustainability, we need to start with a baseline built of facts about the current situation. And with those facts, we can then assess the effects of the activity on the environment, the economy, society, and Indigenous people. We can determine if those effects can be avoided or mitigated, and we can also be identifying consequences for the downstream community so that we can communicate those with them. We have if we can design operational excellence in terms of safety, maintenance, and emergency preparedness, then we can show the economic and social benefits to the stakeholders and to the project owner. But if we've achieved all of that, it's really valuable if we can evaluate it. We can evaluate it using data to show that the baseline situation and how we have assessed the effects and provided mitigants that have been successful in addressing the concerns of stakeholders. Now, there are some tools around, and many of us have heard of the IHA's Sustainability Assessment Protocol. But one of the positive things that the IHA has done is produce some good guidance and some materials to help us in identifying what we can do to address environmental and social issues at the early stage of the project, at each stage from and through the design stage, the implementation or construction stage, and the operation stage. The IHA also set those three pillars of sustainability alongside the technical perspective. So we see environmental, social, and economic sitting alongside the technical perspective. This is an example, using the IHA's sustainability protocol assessment process, which just shows you the number of different facets of environmental and social issues that should be addressed in a project. And they range from the environmental effects of the labour and the social effects and the resettlement, the environmental mitigations, the cultural and heritage, Indigenous people, and includes climate change and others. But it's just really showing you the range of activities that need to be addressed. So to summarise, we are in a world where the societal expectations for dams and reservoirs are increasing in terms of sustainability. We're seeing international agencies responding with IHA, the World Bank, and ICOLD, and others. But there are many factors, especially in this environmental and social safeguard area, that need to be brought together. It's important to start with the end in mind when developing a project. We need to agree the baseline early and then follow through with sustainable practice all the way through the development phase. And if we can monitor and evaluate each phase using real data, then we have the opportunity to demonstrate that the project has been successful in achieving sustainable outcomes. So I'll end it there, and thank you for your attention, and pass back to Steve.
Thank you very much, Peter. Yeah, certainly a very complex set of considerations for the various aspects of sustainability with a hydropower project. And as you say, the public perception and scrutiny now is only increasing to make it more important and more challenging to accommodate all the different challenges a dam project faces. As a reminder, I know I can see another 30, 40 people have joined since we opened the webinar. There will be a Q&A session after the last speaker, but feel free, if you have any questions as we're progressing, just to post them into the Q&A function at the top of your toolbar. There should be a tab there with Q&A written on it. If you type in the question you have, who you'd like it, to address that, the name of the person, and also your own name and any affiliation you may have to ICOLD, that would be great. And as I say, as much time we have at the end of the presentations, we'll allocate towards the Q&A session. We'll now move slightly more to a practical look at how some of these sustainability issues can be directly addressed. And to do that, we'll be looking at the work of the Concrete Dams Technical Committee, where Marco Conrad there is leading a new bulletin to hopefully, I think, be published later this year. Marco is a civil engineer with 25 years of experience in the dams and hydropower sector. He graduated from the university in Munich in 1999, and since then he's been involved extensively in all aspects of RCC dams. His general work focuses on design, construction planning and supervision, as well as surveillance, condition assessment and rehabilitation of dams. Marco is a member of the ICOLD Technical Committee D, Concrete Dams, since 2007, and he's served as its chair since 2018. He's also a co-founder of the Young Engineers Forum for ICOLD. So over to you, please, Marco.
Thank you very much, Steve, and good day to everyone out there. I'm happy to present to you today the work of the Concrete Dams Committee on sustainability of concrete dams.
Marco, you're mute.
Marco, your mic seems to be up. There we go.
Okay. Yeah. Seems to take some reaction time. Sorry for that. Okay. Thank you, Steve, again for the introduction. And once more, a good day to everyone out there. I'm happy to present to you the work of the Concrete Dams Committee on sustainability of concrete dams. In our committee, we started talking about options for reducing carbon emissions from dam concrete in 2007. In 2013, eventually, a paper on the topic of low cement content concrete design options and minimal energy consumption was presented by Dr. Jabaruti, who was the Iranian representative on our committee back then. Since then, the topic was kept alive by discussing updates and related developments in the concrete sector that were relevant to concrete dams. And it took essentially until 2021 to reach a critical mass that initially led us to drafting a first bulletin on the topic.
Marco, you've muted again. Your mic's turned off.
Should take this. Sorry. The drafting of Volume 1 on the role of design and construction in reducing global warming potential from construction of concrete dams involved a team of overall 16 people around the subcommittee lead. At the Marseille meeting in 2022, a bulletin concept was discussed and agreed, and an initial full draft was produced to be ready prior to the last year's Gothenburg meeting for circulation within the committee and allow discussion of the draft at that Gothenburg meeting last year. This then led to the preparation of a final draft with the incorporated comments as received. And this final draft was eventually submitted to ICOLD in January of this year. ICOLD has circulated that draft as Circular Letter 2018 to the national committees, as this work of our committee will be up for vote at the upcoming Delhi General Assembly. Looking at the objectives of our Volume 1 bulletin, the paramount one is providing real, pragmatic, and practical guidelines on how to reduce the GHG footprint of the construction of concrete dams. The focus is on options that are already available today. The implementation is promoted to be more rigorous, bringing forward the process of sustainable development of dams more rapidly and more effectively. Another objective is the initiation of a constructive discussion around the urgent need to address GHG emissions not only from the construction of concrete dams, but from the construction of all types of dams. The bulletin aims at owners, designers, contractors, and also financing bodies. The emphasis with this Volume 1 bulletin is actually on act now, so providing actual options that can already be implemented today. This Volume 1 bulletin focuses exclusively on concrete dams as the core expertise in our committee, and on the reduction of GHG emissions from the project implementation phase, so through the planning, design, and construction phase. The reservoir is not part of the system, so we first look only at the concrete dam system itself. The emphasis is on RCC dams as essentially today's standard approach to large concrete dams, but the recommendations given in that bulletin are also applicable to the reduction of GHG emissions from the construction of traditional concrete dams and other type of concrete dams, as well as cemented material dams. The scope of Volume 1 revolves mostly around the positions that embody most of the concrete dams' GHG emissions. And those are obviously cement content and concrete volume, inefficiencies and lost time, and fuel emissions from transportation, construction equipment and plant, and the power generation at the site. Hence, the bulletin discusses available options for reducing the GHG footprint from concrete dam implementation, which address planning with long lead-in time and making use of informed engineering judgment, reducing the Portland cement content of all the concretes that are used in the project, improving the efficiency of construction of concrete dams, and reducing the GHG emissions from construction plant and equipment. The right-hand side figure should illustrate the importance of the long lead-in times as a key factor for being able to really effectively reducing Portland cement content through a lot of testing and improving methodologies. So also looking at the efficiency of construction through a number of full-scale trial embankments or by the example of an executed dam, RCC dam in Vietnam. The bulletin content covers technical as well as rather non-technical chapters. Being the first bulletin document related to dams and sustainability, actually the introduction that we prepared briefly frames a general understanding of sustainability of dams and formulates guiding principles that Francisco Ortega has essentially talked about just before. Further current GHG emission legislation is discussed by the example of Californian and European legal frameworks and regulatory settings. The reason for looking at California and Europe is actually that both have very advanced environmental legislation and also both represent fairly large economies in our world. Aspects related to bidding, standards, and professional judgment are discussed as well in the bulletin. Technical chapters comprise a wide spectrum of recommendations. The first one addresses construction efficiency, talking about simplicity as the guiding principle for design, layout, and methodologies, achieving speed of construction. Another aspect is the role of virtual design and construction and BIM methods and their possibilities, as well as possibilities from emerging automated construction. The section on materials discusses aggregates, various supplemental cementitious materials, whereas we especially look at the opportunities from using ponded fly ash. We also look at options related to designing concrete mix proportions and discuss the role of design ages in that context, for example. Certain aspects related to concrete dam design are discussed. Early supplier and contractor involvement is an interesting practice that can be quite effective in many respects, also in regards to emission reduction. Further technical sections on construction and construction equipment are comprised in the bulletin, the latter discussing fuel and drivetrain options for construction equipment, venturing a glimpse into the future potential of hydrogen. To us, we consider that bulletin subject to some adaptation in the future, probably because we can clearly observe quite rapid changes and developments on the topic and within the construction sector. So we have to take care of those at some point. So with this volume 1, we are not at the end of our journey in our committee yet. We have other work on our table already in progress and other planned to start within this year. One part of this work is the volume 2 bulletin that will be about determination, respectively accounting of GHG emissions in the construction of concrete dams, led by Francisco Ortega, and a volume 3 that will start and will look at the whole life GHG emissions from concrete dams, including the operation phase and end of life options. So what we can see, our scope within the concrete committee and on the topic opens up as we continue working on our volumes 2 and 3 bulletins. Volume 1 provided technical, very specific available GHG reduction options. This is what we could actually or were in control of doing very quickly. We now progressively expand our scope into new fields of expertise, for example, related to life cycle assessment and others. And here we see that the initiatives, so our initiative so far and now the more overarching initiative within ICOLD, that those initiatives are merging. So it's becoming all quite integrated now, which is great. With this, finally, I would like to conclude with an outlook into probably a not very distant future. I think we can assume that life cycle assessment, especially GHG footprinting life cycle assessment, will become a standard activity in our business. Virtual design and construction, respectively BIM methods, will also further push into the design and also the dam construction planning. We will see systematic data acquisition from dam construction activities taking place, along with the application of data science, such as process mining, for example, as a tool to optimize processes and also optimize on the emissions from construction activities. I also think that we may see a strong refocus on quality to support long-term serviceability beyond the classic design service life thresholds we are using at the moment, the 80 to 100 years of service life typically. So in the context of circularity, I think it will mean that the interpretation of circularity for dams will rather be infinity. Where dams are in remote locations, it is quite possible that transmission lines in the future will be constructed before dam construction will start, or a hydrogen supply chain might be set up for the construction activities. Finally, coming from the assumption that a net zero emission dam project will be achieved sooner or later, the criteria of no net loss in biodiversity will most likely override any emission criteria that we have now. So in the future, the criteria will change, and we look at very different aspects in terms of sustainability. Thank you very much for your attention.
Okay, thank you very much, Marco, for that presentation. I encourage everyone to read a copy of the volume 1. There's particularly the recommendations chapters where real-world measures are summarised, which are really directly applicable to the reduction of emissions. And looking back at the graph that Francisco pulled up earlier, how the emissions and the concentration of CO2 in the atmosphere has increased hugely in the last 50, 60 years since the Industrial Revolution 100 years ago. It's really nice to be able to see practical ways where those emissions can be reduced. As Marco said, looking forward to volumes 2 and 3, one of the almost inevitable next steps in legislation and the drive towards net zero is how life cycle analysis will, as Marco said, become a standard activity, not just for our industry, but for other sectors as well. And so I'm very pleased to be able to welcome Joachim Verdier, who is a life cycle assessment engineer at Lhoist, a leading worldwide producer of lime products headquartered in Belgium. His work involves participating in the design, in the data collection of European sectorial life cycle inventories of lime products, performing environmental impact calculations by using internal and third-party databases, and sustainable portfolio management evaluations. He also coordinates the carbon footprint calculation process with data collection and verification results, and he's responsible for maintaining the carbon footprint process at Lhoist. So over to you, please.
Thank you very much for the introduction, and hello everyone. I'm happy to talk about the life cycle assessment methods. And to start with a definition, a life cycle assessment, or LCA for short, is a tool that measures the environmental impact of a system, which can be many things. It can be a product, a service, or a structure over its life cycle. And what I mean by life cycle, it basically starts from the extraction of the raw materials, goes through the production phase at the factory, and then the transport to the job site, any earthworks and construction, the use phase, and any maintenance and repair as needed, all the way to the end of the life of your structure. LCAs are very powerful tools. They provide a lot of information, and they give you a framework to measure your environmental impacts in a standardized way. And to do that, you have 2 international standards, ISO 14040 and ISO 14044, which gives you the principle as well as the guidelines that you need to follow to conduct a life cycle assessment. If you are following these 2 standards, you have this framework, and you have to conduct your LCA along 4 separate phases. The first is where you define the goal and scope of your study. The second is what we call the life cycle inventory, or LCI for short, which is basically your data collection phase. The third is the life cycle impact assessment, or LCIA for short, where you get the data that you collected in the previous step, and then you transform it into the environmental impact that you choose. And the final phase, the interpretation, this is where you go back, identify any of the significant issues that arose in the previous steps, and then you identify what are the impacts on the results of the significant issues, and from that you can draw your conclusions. Parallel to this framework, also, you have to, of course, report at every step of the way what are the choices that you're making, and this is, of course, going to impact the critical review that could happen at the end of your study, should you choose to do one. Now to go into a little bit more detail about each and every single phase, starting with the goal and scope definition. The very first thing that you want to do when you conduct an LCA is to define why do you want to conduct an LCA, what is your intended application. Do you want to do a carbon footprint assessment? Do you want to compare your product with a competitor product? Do you want to compare your structure with a benchmark? Do you want to publish an environmental product declaration? A lot of questions you can ask yourself, and depending on the answers that you give, you might have to follow some additional standards, additional product category rules, and depending on that, you might have to follow additional requirements. The second question when defining your goal is also defining who is going to be reading your life cycle assessment at the end, who is your intended audience. Do you want to keep this report internally? Do you want to share it to the public? And again, depending on the answer that you give, you might have to consider additional reporting and critical review questions, and especially if you're going to use the results of your LCA to support comparative assertions, that then you need to be careful and you need to conduct a critical review with an external panel. The second phase in your goal and scope definition is defining the scope of your study. You're going to define what it is actually that you're studying along the concept of a functional unit, where you say, what is the structure, what is the product that I'm studying, but also how well is it performing its function, how much of it are you studying, whether it be by size or by an amount or a quantity, and also give a few definitions along the geography and the time frame of your system. And this is especially important, again, for comparative assessments, because to be able to compare two products, to be able to compare two systems, you need to have the exact same functional units. The second part of defining your scope is also defining what is the extent of your assessment, how far into the value chain of your system do you want to go. And this is going to impact where the boundaries of the system that you choose, and also the lifecycle model that you're going to follow when during your assessment. And again, to go into a little bit more detail, there are two main lifecycle models that you can follow to conduct an LCA. The first of which is the cradle-to-gate model that I represented with a black arrow here. The cradle-to-gate assessment starts from the extraction of the raw materials, hence the cradle term, and you make it stop at a gate of your choosing. Generally, you'll make it stop at the production stage, hence the gate, the factory gate, but you can make it stop at the transport, at the earthworks, at the use phase. This is something that you can choose. This is a partial life cycle assessment, and this is generally for these materials, for these products, which are going to be not facing the customer directly, but are going to be used as intermediates, as inputs to other processes. And to give an example of a few functional units, you have, for example, 1 kilogram of steel, 1 kilogram of cement, 1 liter of diesel fuel. These are not final products, but products which are going to be used as inputs for other processes. The second lifecycle model I want to talk about is the cradle-to-grave model. I represented it here with a green arrow, where you start again from the raw material extraction, and you go through every single lifecycle stage all the way to the end of the life of your system. And this is for these products, for these systems which have more defined use cases. The products I mentioned earlier, they have many different applications, but to do a cradle-to-grave assessment, you need to have a more defined use case and a more defined end-of-life scenario. To give an example of a functional unit, in the case of dams, you could say that the functional unit is a dam with 100 meters height. It has a reservoir capacity of a defined amount of cubic meters of water. It's constructed in the USA. In Germany, you choose the geographical component. And at this very stage, you need to be very careful about defining these last two very important steps, the use phase and the end of life, because depending on the answers that you give, again, you might have very different results. Say you need to define the lifespan of your dam, whether it be 50 years, 100 years, 200 years, your use phase is going to be very different. You might have to do more or less maintenance, more or less repairs, and your results are going to be very different. Exact same thing for the end of life scenario. If your dam is being demolished, if it's being repurposed, if it's staying there forever, your end of life results are going to be very different. And so you need to be defining already at this early stage what exactly is going to happen, because this is, of course, going to impact everything that happens after. Once you've defined the goal and the scope of your study, you arrive at the second stage, which is the life cycle inventory. And again, to give a definition, the LCI is where you collect, calculate, and estimate all the data that you need to quantify the relevant inputs and outputs of your system. For any system, you're going to have multiple unit processes. And for each of these unit processes, you need to collect a lot of data regarding any of the materials that come in, any of the energy that is being used in your unit process, any resources that are being extracted from the environment to be used in the process, such as water from a river, water from underground, or any land that is being used, for example. You need to collect data regarding emissions, whether emissions to soil, to water, to air. Also data regarding the waste that is being generated by your unit process and any intermediate products and eventual co-products that are being produced here. The data that you collect at this stage is entirely dependent on the goal that you set yourself at the very beginning. If at the beginning you said, I want to do a carbon footprint assessment, then you don't need to collect any emissions to soil and water. You only need emissions to air and only emissions of greenhouse gases at that. But as you are expanding the scope of your study and you're adding more and more environmental impacts that you want to study, you're going to have to collect more and more data regarding the flows that are coming in and out of your unit process. And as you can imagine, in your lifecycle system, you're going to have multiple unit processes, not just one. And so you have an even greater amount of flows to track and aggregate, which can make the assessment complicated. How are you actually going to collect your data? You've defined the system at the very beginning, and you can separate the system into two subsystems. The first is what we're going to call the foreground system, which is basically where you're going to collect your primary data. And this is for these processes over which you're the person who has the operational control, these processes which are defining your project compared to other similar projects. And to give a few examples, on the civil engineering sectors, you might have on-site electricity generation, excavation, soil treatment. These are the processes over which you're the one who has the operational control. And by collecting the data firsthand, you are improving the reliability of your study, which is something that is great, of course. But the downside of that is that it's something that is incredibly time consuming. You need to go to the stakeholders of the project and demand the data from them. The second complication that arises here is that you need to have qualitative data to improve the reliability of your study. And for that, before even considering starting to do an LCA, you need to ensure that the system that is in place to collect the data is robust enough that it gives you this qualitative data that you need for your foreground system. In opposition to the foreground system, you have the background system, which is where you're going to be collecting secondary data. And this is for these processes, again, in opposition to the first, over which you're not the one who has the operational control because it happens at your suppliers, because it happens somewhere else, or for these processes over which you might have the operational control, but you know that the result, the impact on the final result is limited, and so you don't want to spend too much time collecting data for that. And so again, to give a few examples, for the secondary data collection, you might have concrete production, steel production, diesel production. All of this is happening at your suppliers, and there is no way for you to get primary data from that. The downside here is that you're collecting data from third-party sources, secondary data. This is something that's going to go much faster than the primary data collection, but here you're going to have to ask yourself these questions. Is it relevant compared to my situation? Is the data that I'm collecting representative versus my situation? And you need to ask yourself this alongside multiple axes. For example, in terms of geography, is the geography from the data set that I'm going to use the same, or is it completely different? Is the time frame the same, or is it, again, completely disjointed compared to my situation? Is the technology that is being used or studied in this data set completely different from the one that is happening at my supplier, or is it something that is similar, comparable? And the last thing is completeness. Is the data set that I'm using modeling enough flows that I can do the lifecycle impact assessment that I want to do later on? And depending, again, on the answers of these questions, if you're satisfied with the representativity of the data sets that you're going to use, you can approve the use of the secondary data for your background system. All this data that you collect, you need to, of course, quantify and aggregate. You need to validate it. You can do multiple checks, simple ones such as mass balance, energy balance. You can compare this data to an industry benchmark. And of course, you need to relate the data to the functional unit because the lifecycle assessment is a relative assessment always. Once you've collected all of your data, you arrive at the third stage of the lifecycle assessment, which is the lifecycle impact assessment. As I said at the beginning, this is where you transform all the data that you collected into the environmental impacts. I gave an example earlier about excavation, and in excavation, you're going to have some vehicles that are going to use diesel and are going to burn it. And for diesel combustion, you can collect data regarding multiple flows. And I chose 3 examples, which is CO2 emissions to air, nitrogen oxides emissions to air, and methane emissions to air. And at this stage, you need to assign each and every single flow to its corresponding environmental impacts. Say for CO2, it's pretty easy. You can assign it to climate change, and that's it. Job done. For nitrogen oxides, it's already becoming more complicated. You can assign it to acidification. You can assign it to eutrophication. You can assign it to photochemical ozone formation. Methane is the same story. It's a greenhouse gas, so you can assign it to climate change, but you can also assign it to photochemical ozone formation. And you can assign it to human toxicity. And as you can imagine, this is only 3 flows. For any given unit process, you might have a lot more flows than this, and you have multiple unit processes. So again, this is something that can become fairly complicated, and for that, you need to have a robust model that you can use that can do this aggregation for you. The very first step of the lifecycle impact assessment I described earlier is called classification, and the second step is called characterization. Here, you've assigned your flows to environmental impacts. And then you need to convert the amount of each flow into the corresponding impact indicator. Taking again the example of methane. Methane we assign to climate change because it's a greenhouse gas. And then we need to express the amount of methane into the corresponding impact indicator of climate change, which is kilograms of CO2 equivalent. And so to do that, you need to multiply the amount of kilograms of methane by 29.8 to get the result in kilograms of CO2 equivalent. There are many different characterization methods that are available. In general, this is something that you need to choose as well at the beginning of your study, and the choice might be along more geographical lines. There are default characterization methods. In North America, most people might use the Tracy method, which was developed by the EPA. In Europe, you might use the EN 15804 method more. This is something that is entirely dependent on the goal that you set yourself, and these methods are generally supported as well by life cycle assessment modeling softwares, which are available to help you in this impact assessment stage. And so we arrive at the final phase of the life cycle assessment framework, which is the interpretation phase, where, as I said again at the beginning, this is where you identify any of the significant issues that arose in the previous phases. Have you had to make a critical assumption regarding some missing data? Have you had to substitute data with something else that is not quite as representative? These issues, you need to identify what are the impacts on the result. Is it impacting the completeness of your study because some data is missing? If so, is the impact important, non-important? How does it affect your result? You can do some sensitivity analysis as well by multiplying the data by 2 and seeing if it changes the conclusion of your study or not. You can check if it impacted the consistency of your study, depending on any of the methodology that you chose to apply. Did you have to change the methodology because of this significant issue? And finally, this is also the stage where you need to do your contribution analysis. You need to see what are these processes that impact my results of my life cycle assessment massively. For example, if you have a concrete dam, then you're going to find out that for multiple impact categories, the production of cement is going to have a massive impact. This is important, of course, for the people who are going to read your life cycle assessment, your report, because it helps them understand what is impacting your results. But it's also important for the person who's doing the life cycle assessment, because if you're ever going to do a second pass of collecting data, of calculating your results, then you know what are these areas over which you need to have a more special focus on. What are these processes for which you need to be especially careful about? And depending on the results and the evaluation that you've done, you can finally draw some conclusions, give recommendations based on that. Speaking of conclusions, I just wanted here to give an example to show that there are many different conclusions that you can draw. This is an internal exercise that we did at Lhoist, which is a cradle-to-gate theoretical assessment of different solutions for the construction of a dam. We studied 3 solutions, which was lime-treated soil and then the hard cover of either concrete or asphalt, and we calculated the results along multiple environmental indicators. This is not meant to be a final study. It's not published. It's not peer-reviewed or anything, but just to give an example for the purpose of this presentation, when you're looking at different environmental indicators, you're going to draw different conclusions. If you're looking at global warming potential, you can see that the asphalt shell is the least environmental impactful, and the concrete shell is the most. If you're looking at acidification, lime-treated soil is quote-unquote the best solution, and asphalt is the worst. So on and so forth, depending on the impact that you're looking at. There are many different conclusions that you can draw, and the conclusions that you will draw yourself are up to you and the goal of your study that you set yourself at the very beginning. If you set that global warming potential is important for you, then you're going to choose the asphalt solution. If you're going to look at the acidification potential, you're going to look at lime-treated soil. This is something that you have to choose, and no one can choose for you. And then this is something that you need to do at the very beginning, because again, this is going to impact your data collection. You know that this impact is important for you, so you need to put more focus on these flows that are going to impact your global warming potential, for example. The second thing I want to say about this is that life cycle assessments, they provide, again, a lot of different conclusions, but they're conclusions along environmental lines. To give a more complete answer regarding sustainability as a whole, you would pair this with an economic assessment, a social assessment. You could, for example, do a life cycle costing analysis or a social life cycle assessment, but this is, of course, beyond the scope of a traditional LCA to give a proper answer. And so finally, reaching the conclusion of this presentation, life cycle assessments, they're very important. They're very good, powerful environmental impact assessment tools, but they have some limits. It's, of course, a relative assessment at every step of the way. You have to relate everything, your data, your results, to the functional unit that you chose at the very beginning, which is very important. And of course, this is not something that's going to be 100% smooth sailing from the beginning to the end. At some point, you're going to encounter some issues regarding the choice of data, regarding assumptions that you're going to have to make. And so you need to justify in your report what are the choices that you've made for every issue that you encountered. It's something that is surrounded by a very strict set of guidelines. You need to follow the two standards that I mentioned, but again, depending on the application that you want to give to your LCA, you might have to follow even stricter guidelines. But all of this is very worth it because, again, it's a powerful tool and it provides a lot of decision-making power to a lot of different people who can use these LCAs to make decisions. I gave a few examples here, but to give just one, at executive level of an organization, of a company, you can use the LCAs that identify environmental hotspots to make decisions to reduce your environmental impacts. All of this to say that at the end of the day, you're the one who decides how you do the assessment. Yes, you have to follow the guidelines. Yes, you have to follow the standards, but you're the one who chooses what is my goal, what is my scope, what type of data you're going to collect. And as long as you're justifying all of your choices, that you're making these choices along scientific lines, then you should have no problem to do your life cycle assessment. You should have no problem during a critical review to improve the reliability of your study. And that should be it for me. So yeah, thank you for your attention.
Thank you very much, Joachim. That's very interesting and raises a lot of questions. I certainly have questions to ask at the end. We have two more presentations. Just a reminder, if you do have any questions, please feel free to post them into the Q&A tab at the top of your screens now. And as I say, they'll be addressed to the speaker at the end of the presentation. We have two more presentations. Please do make a note of which speaker you'd like to answer your query or question, as well as also including your own name and any affiliation you have to ICOLD. That would be great. So now we move slightly to the side with an accounting and an economics overview, looking at the externalities with short and long-term analysis. And taking us there is Lamis Aljounaidi. Lamis has 18 years of experience in infrastructure development and economics with a focus on renewables and networks. Through her employment with the French Development Agency, the World Bank and the French Energy Regulator, she's been involved in a large number of infrastructure projects, financing and multiple financing instruments. She led Tractable Engineering France's advisory practice from 2015 to 2020, where she supported the development of multiple large hydropower projects in Asia and also in Africa. So over to you, please, Lamis.
Hello, Steve. Thank you for the introduction. Can you hear me?
Yes, all loud and clear.
Yes, great. Thank you for the introduction and thank you for inviting me to this seminar. So going back to some of what the other speakers presented, large infrastructure, particularly large dams, generate long-lasting benefits. So these include water storage, they include flood prevention, and power generation. They also affect the environment, emissions, greenhouse gas emissions during construction. So emissions through the reservoirs, the reservoir footprint or the footprint of the reservoir and its impact on natural habitat and cultural heritage. One example that comes to mind is the Abu Simbel temple that was in the Lake Nasser footprint and needed to be relocated to for the high dam in Egypt to be built. Dams create obstacles on waterways and also affect salinity of river mouths. They impact marine ecosystems and may change the local geography due to regressive erosion. So, aspect when we look at these impacts is in most processes to get projects approved, you have a screening for environmental impacts, and you have a list of and thresholds of what you're looking into, and whether if your infrastructure has these impacts on the environment, then you don't investigate further, you don't go further. And this list of social and environmental criteria is evolving over time. So we used to accept more impacts in the past than what we are accepting right now. An example is these dams we are dismantling, whether in the US or in France, and because we don't accept their impact on the environment anymore. So what I'm presenting comes after that ENS screening. I will be looking at the stage where the infrastructure is identified. There's an ENS screening that did not lead to not retaining the infrastructure, and we are in the next phase of evaluating whether to invest in that infrastructure. When we look at the decision-making process for those type of investments, I think everybody will have in mind the process, the investor's perspective. Will ask the question, very simple question, does this project generate sufficient revenues? And we're talking euros, dollars. Does it generate sufficient revenues to cover costs, debt service, and a reasonable return on the investment? Yes, then the project proceeds, and if the project does not proceed. If we look at publicly sponsored projects, which is the case for large dams and reservoirs, simply because they affect public goods, which is the water resources. We have another perspective. We don't decide on investments with the same framework. It's not about generating sufficient revenue. It's about generating high enough net benefits for the collectivity. And so there's a framework that exists, that has existed for centuries now, that provides an approach to evaluate this, to evaluate the impact of infrastructure on social benefits. Most of you would know these studies as cost-benefit analysis, economic analysis, assessment of social surplus, or assessment of net social benefits. These studies differ a little bit, or they're mostly similar. What are we asking here? What's the process? First, is the infrastructure good for society? And if we end up saying yes, then do we need to have support schemes to make it interesting for project sponsors? If the answer is no, then let's put penalties to make it uninteresting for project sponsors. Now, the first important thing that we ask is to define the collective. We are asking this question, is it good for society, from the perspective of a specific collectivity, a group. Who is our group? And this question is really important. It's really important because we are evaluating costs and benefits of members of that group. Not costs and benefits of a specific investor, but of the members of the group. And I have one specific example in mind, not necessarily large hydropower. A few years back, we were evaluating interconnector project between France and the UK. And EU rules say that these interconnector projects are approved if they generate a net social surplus for the EU internal market. So we started the evaluation, and back then we thought that an interconnector would be working in providing nuclear power from France to the UK. And so we calculated the social benefit of that project with these assumptions in mind, and we found the project interesting. And as the project was going different steps of approvals, Brexit happened. So now the EU internal market changed, and now the project was taking out cheap, clean electricity from the EU to a third party, which was the UK. And so the project did not provide the net social benefit in that regard. It did not check that box of increasing net social benefit for the internal market. And so the project got significantly delayed because of that. So defining the box is very important. And this gets to my next slide. What do we do with international public goods? One of which is greenhouse gas emission reduction. Another one is biodiversity. What do we do for these? Today, we don't have a set framework. We don't have clear rules on evaluating the planetary surplus of a project. There are some schemes, works in progress that it's great that we have those, but they are definitely well beyond what is required to adequately account for these international public goods. So some of these schemes are carbon border adjustment mechanism or finance schemes tied to the nationally determined contributions or incentives for nature-based solutions. There is no penalties like set at the international level, for example, for if we don't meet certain targets. And so this framework is definitely a work in progress, and for the moment we are really lagging behind in internalizing these the value of international public goods. So when we want to consider the externalities in the economic analysis, the first thing we want to do is find a way to put a value on it. So for most environmental impacts, I'm sure you are aware of the avoid, mitigate, compensate approach, which says that if you can design the infrastructure to avoid impacts, then it's great. Let's pay for the extra costs. Let's include the extra costs. If you can't avoid the impacts, but you can design additional investments to minimize these impacts, to mitigate them, then let's have these extra costs. Let's pay for these extra investments. And for whatever that we couldn't avoid, we couldn't mitigate, we should compensate for. And so at the end of these environmental and social assessment, there are mitigation plans that are provided, and these mitigation plans have dollar values attached to them. And so from the economic perspective, it's easy to just take those dollar values and put in a cost-benefit analysis. However, with non-mitigated impacts, meaning that despite these studies, we end up with infrastructure that impacts the environment, that we still have impacts that were not necessarily adequately mitigated or fully compensated. So in some instances, we are asked to include these impacts in the evaluations. One such ask that we have been seeing more of really recently is the inclusion of biodiversity. So there is a framework for biodiversity that was set by the UN Convention on Biological Diversity. There is an increased momentum, and which is quite recent, on the importance of biodiversity, with more stakeholders gaining understanding of the fact that we are facing a massive biodiversity loss, not related to hydropower or even the energy sector, but it's related to our agricultural practices. So in COP 2022, a significant milestone happened, which is that countries committed to set national biodiversity strategies and action plans, and committed to also discuss these strategies and action plans for the future COPs. The EU set its biodiversity strategy for 2030. It was the same for France, and the biodiversity strategy is part of the environmental law. And one important aspect that the large DAMS will acknowledge is that the EU biodiversity strategy pledges to restore freshwater ecosystems and to remove enough barriers to achieve at least 25,000 kilometers of free-flowing rivers. So that goes back to the picture I was showing earlier of France investing, putting money to take out large dams from the waterways. So when it comes to accounting for biodiversity, non-mitigated impacts on biodiversity, when it comes to the public decision making for large dams, the UN System for Environmental and Economic Accounting set a biodiversity accounting system that has its first stage is to account, to provide accounts in physical terms. And so there's this framework that can be used to do these biodiversity accounts. The part about monetary value, I will get to it later. So if we want to include biodiversity in cost, benefit, and decision making, non-mitigated impacts on biodiversity, first thing is to understand, to measure biodiversity, and there is this framework. The second part will be to evaluate the impact of these large dams on biodiversity. So let's say there's a feasibility study that is being prepared to decide whether or not a large dam is of interest. Then we would include an evaluation of the impact of that dam on biodiversity, not just also an inclusion, a measure of physical impact, a measure of the physical impact of biodiversity on large dams. The next step would be to put a monetary value on that biodiversity. And so there are some studies that exist, although the reference studies are not that high. So we do have some studies. We do have some studies that value economically ecosystems, evaluating what we get out of certain ecosystems, for example, for coastal wetlands, through evaluation of their impact on fishing, etc. So if we have stage 2, then we can do stage 3. At this stage, I don't know what would be the experience of people around the table here, but in my experience, I have never seen the stage 2. I have never seen the stage 2 of this diagram in practice. Something that measures the biodiversity, provides physical metrics of biodiversity impact with and without the dam infrastructure. So when it comes to CO2, Joachim was presenting earlier life cycle assessment methods. So methods to measure CO2 are already well established, and usually as economists, when we are providing these decision-making assessments, we do have a measure. And the question that we need to answer is, how do we value the CO2 emissions? Say, usually they are reductions happily. So obvious answer is look at market values for emission trading schemes or for voluntary carbon markets. Answer, which is expected to be more complete, which is to look at the social cost of carbon. So the social cost of carbon is an approach devised by economists that measures, that evaluates the damages, the cost of damages for each additional kilogram of CO2. The social cost of carbon is now internalized in US public decision making. So it is actually, this is how the impact of projects on CO2 emissions are valued for US public decision making, using the social cost of carbon. Now, if we look at how the value of damages are computed, we will see that the references overvalue damages in the US, obviously because there are databases there and because US infrastructure is insured and US infrastructure is valuable. And so this social cost of carbon specifically reflects the value of damages in the US, or like predominantly reflect the value of damages in the US from an additional kilogram of CO2. Now, a few months ago, we had the dilemma. We were evaluating a dam project in West Africa, and we really wanted to use the social cost of carbon because it gives a high value to the CO2, close to one values that we have on the ETS schemes right now, but well above the voluntary carbon markets, which are very minor right now. And so we had an ethical question, because imagine we are facing a project where the without the CO2 savings, the project does not pass the bar, is not acceptable. And then we add the CO2 saving and we make it acceptable. This means what? This means that this project is to be paid for by the economy for West African country, one of the least developed economies, will be paid for on the promise that it will reduce CO2 damages caused by CO2 emissions. However, those damages, those savings are not happening in that poor country, they are happening in the US. So after like proposing it and it looked nice and we were happy with it, we found out that it was not ethical to use that value, although we wanted to use it. So what can we use for countries where although damages will be high, the value, the economic value of damages is not high, because these are poor countries. They don't have that many infrastructure that will be damaged later. And the response we came up with is to use actual money coming to these economies, because we go back to the box I was talking about earlier in the presentation. The investment decision is to be made at the level of that country, and the people of that country will be paying for the infrastructure. So it makes sense that if we internalize social costs, it needs to be social costs that are borne by those paying for the infrastructure. And so we looked at obviously voluntary carbon markets, and we looked at interest, the subsidy equivalent of financing from the Green Climate Fund. We also looked at certain schemes, sustainability-linked loans, that were valuing the country's achievement of their nationally determined contributions, and were reducing cost of funds if the country achieved those. So that meant savings in financing costs. In other contexts, we could also look at the carbon border adjustment mechanism, which is going to apply to a narrow set of import goods to be imported to the EU. In the first stages, it will be mostly construction material, but not food, not clothing, for example. And then as we go, other components will be included. So for many countries in West Africa, for example, the CBAM is not really a relevant mechanism. It's a relevant mechanism for countries in Central Asia, which export these the taxed goods to the EU. So once we have these values of costs and benefits, whether externalities or whether internal costs and benefits, the next step will be to put costs and benefits together and see whether the project is interesting or not. So as you know, we and you will probably, if you were not aware of this, you will probably understand it easily, that we don't put the same value on the present as on the future. If somebody asks us whether we want to have a great meal today or a great meal in 10 years, most people would like the same great meal today than the same great meal in 10 years. Maybe a promise of a great meal in 2 great meals in 10 years instead of 1 great meal today. So we do have a preference for the present. This is like a natural human preference for the present. And so whatever benefits and costs we receive need to take into account our preference for the present. That preference for the present is not constant. So in the European context, where we're in very safe environments, we have economic and political stability, we give a much higher value to the future than in contexts where there are high crime rates, there are more political instability, etc. Why people give much higher value to the present? It's because the present is known, the future is highly risky. They might not see the future. And so the way we look at costs and benefits today and tomorrow is very, it's cultural and it's specific, it's different from one country to the other. The same applies to the environmental perspective. There are feedback loops in the environment that makes 1 kilogram of CO2 emission today more important than 1 kilogram of CO2 saved tomorrow because of these feedback loops, meaning that the more we save today, the less we need to save. I mean, this is obvious, but the 1 kilogram that we save today is significantly more important for the environment than 1 kilogram saved tomorrow. So the same principle of importance of the present is also there for the CO2 emissions. So the formula, I think most of you will be familiar with it. The formula for the discount factor is to take the costs and benefits and discount them, meaning that we reduce them as time goes. So a cost from 2024 will be weighed as 1, and a cost with a 10% discount factor 7 years later will be weighed with a 50%, meaning that the costs and benefits of the future are less important than costs and benefits of today. And so this discount factor is a very important value when it comes to approving investments. And so there are various approaches that have been used over time and in different contexts to evaluate the discount factor. I will focus on what France does because it's well documented and it has been evolving over time. So in France, there's an entity that used to be called Commissariat Général du Plan that is now called France Stratégie that has been setting this value for the discount factor since the 1980s. And so in the early years, they were saying, okay, it's the private return plus 2%, which means that if an investment can be done by the private sector, public capital, there's no chance of public capital crowding out that private investment. And that led to the use of a discount factor quite consistently equal to 8% in that period. In the early 2000s, ex post evaluations found out that the 8% value was too high and excluded a lot of public investments. So there was a new approach that devised different discount factors, and that approach aimed at ensuring that more public investments are approved. Then in the 2010s, an updated approach was set in place, and that updated approach says we need to take into account how this infrastructure behaves with systemic risk. So systemic risk means that there's a, like COVID, for example, there's a contraction in the economy. Some infrastructure, if there's a contraction in the economy, the benefits of some infrastructure will contract as well, and for other infrastructure, it's the opposite. Their benefits will be higher. For example, during COVID, obviously, the road infrastructure was not really very useful, but hospitals were extremely useful. So the idea was to give lower discount factor to projects that are counter-cyclical, that when there is a systemic risk, they help prevent that risk or provide a safety net for that risk. And so they introduced a formula comparable, maybe some of you will be aware of it, of the capital asset pricing model. Very different framework, but the formulas look quite close. And so the discount factor is the sum of a risk-free discount factor and a macroeconomic risk premium adjusted with the impact of adjusted to beta, which measures the elasticity of the project to the GDP. More recently, 2021, we have a new approach that further defined the risk-free discount factor and further defined the macroeconomic risk premiums. And the France Stratégie is now planning on doing more deep dives into betas for specific investments. One very important aspect to note here is the risk-free, obviously, measures pure preference for the present, measures collective risk aversion, and also takes into account GDP growth and volatility of GDP growth. And if you look at volatility of GDP growth, you will know that in least developed countries, GDP growth is way more volatile than we have in developed economies, which is where we have a significant difference between a discount factor that you would take for an investment project in France and a discount factor that you would take for an investment project in Chad, for example, because of this volatility in GDP. Okay, and there is also future work to include impact of rare disasters on the discount factors. So I think most of you will be aware of the fact that the net present value. Okay, so we approve investments using this metric, which is the net present value. And the net present value is tremendously affected by the choice of discount factor. So if we use a low discount factor, we overvalue future benefits compared to current costs. And so projects have a higher chances of being approved with a low discount factor. When we use a high discount factor, we put more weight on the current costs, less weight on the future benefits, and so projects have a higher chances of being approved. Thank you for your attention.
Okay, thank you very much, Lamis, for that very comprehensive look at discount rates and the economic side of sustainability. As we've heard, DAMS and sustainability is a very diverse, multidisciplinary challenge, including the fields of finance, economics, climate science, anthropology, biodiversity, biology, to name just a few. And how we're going to address those different topics, sometimes competing topics, will require definition of which parameters to focus on. And I'd like now to welcome back Luc, who will guide us through some of the ideas on how the committee and the future work of ICOLD will do this. As mentioned earlier, Luc is Chief Technical Officer at ISL, a French design engineering company in the fields of dams, hydraulic and maritime infrastructures. and he's also the chairman of ICOLD Committee on Prospective and New Challenges for Dams and Reservoirs. Thank you, Luke.
Thank you, and well, I will try to guide us. This presentation indeed focuses on our future work and its ambitions. Actually, we would like to define a general scope, and as I said before, this scope is, of course, open to discussion. Dams and sustainability is a very broad topic which needs to be specified. And through this presentation, we have a series of 4 proposals. We propose to focus on costs. We propose to be ambitious in terms of sustainability criteria. We propose to consider a perimeter encompassing the dam and its reservoir. And we propose to work with metrics, with indicators. These are proposals, and I will try to develop each of them now. First, focus on cost. This follows Lamis' presentation dealing with benefits and costs of infrastructure projects. This slide says almost the same thing with maybe slightly different words. Dams and their reservoirs have costs and benefits. We divide here the benefits into 3 categories: monetary or monetized benefits, monetizable benefits, which are not explicitly monetized, but could be, and non-monetizable benefits. These are not monetized, and maybe it's best not to attempt to monetize them, as the outcome would be too uncertain. And these are some examples of monetizable benefits, for instance, electricity production. That's monetized benefits. Monetizable benefits, for instance, power storage, or the fact that flood prevention could save money. And non-monetizable benefits with the example of, for instance, life insurance for extreme conditions, life insurance that is provided by some reservoirs. We also break down the costs into 3 parts: monetized, monetizable, and non-monetizable costs, with some example here. Since we are comparing costs and benefits, here's the cost over benefit ratio. Of course, it is of utmost importance to try to maximize the benefit. And this is not easy because some of the benefits, sometimes most of them, are not monetized or not non-monetizable. So utmost importance of maximizing the benefits, but we propose, and I stress, we propose to focus not on the benefits, but on costs only, and especially on non-monetized and non-monetizable costs. This means that, actually, we are not seeking to answer the question, should a reservoir be made, but rather to the question, how should a reservoir be made to mitigate all costs? Well, of course, while assessing the cost and these costs here, we might also find on the way ways to better account for benefits also. Question number 2 is about ambition. We could decide on different levels of ambition. And I propose 3 possible levels here. Level 1, we only consider GHG emissions. This is the easy part. Level 2, we also consider other quantitative parameters such as land conversion caused by the reservoir impoundment. Level 3, also consider all other parameters, non-quantitative or difficult to quantify, such as a loss of biodiversity or general impact on community livelihood. We propose, and again I stress the word propose, to start our work program with GHG emissions, level 1, because it's important and also because we have the tools to do it. We propose to try to reach level 3 as far as possible, because that's how we'll get a convincing assessment of sustainability. Of course, level 3 is very difficult to achieve and we'll need help. We can't build our own criteria. We have to base our works on assessment methods that are already widely accepted. As Francisco Ortega indicated before, we think they should be based on the 9 planet boundaries of the Stockholm Resilience Center and the UN SDGs. We hope to find practical implementations of both in terms of global control variables, global metrics, global indicators, and in terms of disaggregation for local application of these global variables to each context. The third question is the perimeter. What is the extent of the project to be evaluated? And this is a twofold question, geographical perimeter and temporal perimeter. As far as the geographical perimeter is concerned, we suggest selecting the dam plus the associated reservoir, or in case of a cascade of dams, the entire cascade. In fact, it's not enough to select the dam only, because the environmental costs are mainly associated with the reservoir, and they need to be taken into account. Also, including the reservoir will encourage designers to think about optimization, not only for the dam, but also for the reservoir. As far as the temporal perimeter is concerned, we naturally propose to consider the entire life cycle from cradle to grave. This seems plainly logical, and it raises interesting and sometimes difficult questions. How can we take into account for the actual lifespan of dams, which is often much well over 100 years? What is the impact of design and construction quality on the structures and reservoirs lifespan? How should we account for the value or cost at the end of the service life, for instance after sedimentation? Should we include decommissioning cost? Eventually, with reference to Lamis' presentation, should we incorporate a discount rate also for non-monetized and non-monetizable costs and benefits? Is there a discount rate for biodiversity? The fourth question refers to indicators or metrics, and I have 2 slides on this subject. We know that metrics are useful, very useful. Numbers based on facts imply a certain degree of objectivity and guarantee a minimum depth of assessment. And they are more operative than textual language. The monetary cost of a project, the GHG emission of a project, the number of displaced people are metrics that we are used to. Yet, the metrics we sometimes use are not precise enough to be operative, to lead to relevant assessments. For example, it is very easy to calculate the surface area that will be transformed by the project. It is a certain number of hectares. But this says little about the scale of the associated environmental cost. This type of metric needs to be refined to better reflect the effects of the project. And finally, we sometimes lack the matrix, which indicator to measure the biodiversity importance, which indicator to globally assess the impact of a reservoir on global water quality. We recognize both the importance and the limitations of using metrics. And we propose to do as much as possible. The idea would be to consider a list of global parameters, equivalent tons of CO2 for GHG emissions, for instance, also hectares of land below a maximum water level for land conversion. And then consider lists of sub-parameters and sub-parameters as illustrated here in the case of the land conversion, the land transformation imposed by the project. We also propose to scale the sustainability matrix by sample indicators of the benefits like electricity production in megawatt hours or water supply in cubic meters per year. These indicators might also require some kind of refinement. And if all goes well, in the end, it may be possible to calculate some kind of sustainability scores for a project. At this stage, it's important to clarify one statement. Metrics, indicators are a way of simplifying a complex reality. They help make decisions. However, reality is complex, and this complexity must be recognized. Each project is specific, and environmental and social impact assessments aim at assessing this complexity. They are in no way replaced by our sustainability metrics. This last slide tries to answer the question how useful all of this can be. We hope that it will help. We think it can help us better understand where the main issues lie. Just as Joachim said about LCA, just point out where the main factors reside, and then where our efforts should be deployed. We think the sustainability metrics can be a useful tool for comparing different dam and reservoir alternatives on a specific site, departing from a cost-only comparison. We hope this will foster innovation towards more sustainable options for dams and for reservoirs. And that will be also a driver for maximizing the benefits of a project, since, of course, maximizing the benefits will improve the overall score. We know it won't give a complete picture. It won't help in deciding whether a dam should be built rather than doing nothing. Such decision has to compare the reservoir's local social benefits and its global footprint, and this is a difficult question involving both global and local considerations. Sustainable dam options are more expensive than cost-optimized dam options, and Lamis gave us an example with West Africa. This must be accepted. We have to accept for extra cost. And the question is how this extra cost has to be financed. Who should pay for it? Our work will not answer the question of cost sharing. Finally, as I said earlier, for each specific project, sustainability will not be assessed using metrics only. The complexity of social and environmental issues will still require a full environmental and social impact assessment, and also the involvement of the local communities, the affected stakeholders. Thank you.
Okay, thank you very much, Luke, and thank you to each of the presenters today. That does bring us to the end of the presentations, and we are running just a few minutes late, but I'd like to still open the floor if there are any questions. A reminder to use, please, the function at the top of your screens, and there should be a toolbar visible with the icon of a question mark underneath with the Q&A written. If you do have a question, please name the person you'd like the question to be addressed by, as well as including your own name and any affiliation you may have to one of the technical committees or others within ICOLD. Perhaps to get things started, I may start with the first question. I'd like to ask Joachim, if I may. Thanks firstly for a very interesting presentation. I certainly will take a second look at it later. I look forward to going into it into more depth. Well, a two-part question really. What are some of the differences that can arise when using the different life cycle impact assessment methods you mentioned? And secondly, if there are differences that are significant, how can practitioners choose the correct tool and also to have confidence in the relative accuracy of one tool over another? That's for Joachim, please.
Thanks for the question. I have a backup slide prepared for the first part at least, so if that's fine with everyone, I'll share it. It's I hope everyone can see it. Basically, when you're choosing different life cycle impact assessment methods, you might have some differences regarding the environmental impacts that are inside the method itself. For example, if you're taking the EN 15804 method, you might have the eutrophication here, which is separated in 3 separate impacts, one for freshwater, one for marine, one for terrestrial. And if you're following the Tracy method, then eutrophication is aggregated into only one value, which has the kilogram of nitrogen equivalent as its indicator. Another method, which is more Europe-based for CML, also has a eutrophication potential, also aggregated, but this time the impact indicator is in kilogram of phosphate equivalent. And so this is the type of difference that can arise, is that depending on the method that you have, one indicator or a set of indicators can be presented differently, can have an impact indicator that is different. And this is something that you have to be careful about when you're taking life cycle assessments from internet, from different publications, and you try to compare them between each other, make sure that the LCIA method is the same. Another thing is that the characterization factors could be different as well. If I take the example again of methane that I gave earlier, the characterization factor in EN 15804 is 29.8 for climate change, and in Tracy it's only 25, for example. So again, not really able, even in the same impact category, to compare one-to-one. So the second part of the question was, if you could repeat it, please.
So with the different methodologies and the potential different results that they reach, I was just wondering, how can practitioners and the public have faith that the results are accurately reflecting the true life cycle analysis of a particular project?
Mm-hmm. Well, here this is very much, there are some methods, of course, that are more accepted than others. I mentioned that depending on the geography, you might choose one or the other. This is because there is a geographical component in the characterization factors as well. And these methods reflect more accurately some geographies over others. So if you really wanted to evaluate a project in North America, then you should really use the Tracy indicators, because they have these characterization factors which have been researched for the USA, for North America in general, and this will make your results more accurate to the geography you're studying. Same thing for EN 15804, same thing for CML. They were made with Europe in mind, with European countries in mind, and so this improves the reliability of results for this region. This doesn't mean that you won't get any results if you're using these methods for other countries. You will, it's possible, but you have to know that at the back end, when these methods were made, when they were developed, they were made with these countries in mind. I hope that answers the question.
Yeah, thank you very much. Yeah. Okay, so I can see that we still don't have any questions from the delegates. Do any of the other panelists have questions for any of their fellow speakers? If not, I have plenty more questions which I'd like to ask each of you. So if you'd like to jump in, please feel free to jump in. Otherwise, Peter, a quick question for you, as we're amongst ICOLD, where safety is, of course, paramount. Is the safety of the structure considered to be part of or separate, do you think, from environmental sustainability? How do the two intertwine and connect?
Yeah, well, Steve, in some jurisdictions, the safety is actually is required by and is regulated to.
Oh, your mic's just dropped out, Peter.
Sorry, beg your pardon. Yeah, it's treated as an effect. So it's, if a safety issue results in an unexplained or unplanned discharge, there's an effect on the downstream environment. That's the the ecological environment and the community as an environment. So it is a factor. It is a factor. It's treated as an effect alongside all of the other ones. Other jurisdictions are not quite so explicit. It can be sort of up to the regulator involved as to whether they want to incorporate it or not. But you certainly see it in some environments, some jurisdiction environments.
Okay, great, thank you. Okay, Lamis, I just have a short question for you, if I may. We hear often about the ancillary environmental benefits in a broader economic sense, as you touched on in your presentation. And I just wonder, are there standardized frameworks for accounting these? So you talk about indirect benefits, things such as habitat preservation or recreational use. How can a project owner monetize these, both theoretically and to actually generate revenue? And are there examples perhaps where this has been done?
So the question relates to secondary benefits such as tourism, fisheries, etc., right? You have some specific examples where tourism around the reservoir area has been developed. For instance, one such cases. It's usually something that, as part of project assessments, most clients want to assess, want to evaluate. It's also a way of putting the reservoir into light, having favorable communication around it. I don't have specific cases where I worked on a project and such investments materialized, investments in hotels, water activities around reservoirs, for example, but you have good case studies in France, for instance, and probably in other countries in Europe. As fisheries is a better documented example, where you set up fisheries on the reservoir, and so it's quite the evaluation approach is quite straightforward. You just look at how many cages you can put according to the depth of the reservoir, but also to the how water is expected, the water plan is expected to evolve, and then you look at and you have quite good metrics for that, the efficiency of fish production, how many fish you are going to get from that in that specific environment, considering the climate, how much it will cost you to feed the fish, to buy the fish, etc. So like the metrics are the approach is quite standard and straightforward for fisheries, and you have some studies that you can find. Not all of them are extremely recent, but some are quite recent, so dating less than 5 years ago. And this has been done before. Another one that's not exactly secondary benefits, you can decide to, and I have more hydropower and dam experts here, but you can also decide to build a dam to facilitate navigation. And so sometimes it's a secondary benefit, but sometimes it's the reason why the dam is created. And so you operate the dam to make sure that you have enough water in the river to enable navigation, and you are going to evaluate what it will bring to have navigation on that water flow. And as you are well aware, in Europe, waterways are used to exchange merchandise. They are used in place of roads. They are used in Paris for waste collection or for the transport of cement, construction material. So there's a lot of interest in facilitating navigation, and that can be easily measured. Like, you can think of the local environment, what it will mean in terms of economic activity to have better navigation in the dry season, and to have continuity of navigation between the different seasons. Another secondary benefit did you mention something else? Always water, having access to water storage, not exactly secondary benefit. That could be if the main aim of the dam is hydropower, you can value that as a secondary benefit as well. We can use the reservoir area for floating PV, which also you could count as main investment or secondary benefit, depending on how you set your framework. Yeah, so there are quite good literature on how you evaluate secondary benefits. And I see that Peter is confirming, so I guess he will have other examples in mind.
Very, very true, Lamis. Yeah, we see quite a number of examples that you raised, really taking things into the multi-purpose reservoirs than a single purpose, really. Many of the things you've just mentioned.
I maybe have a question for Luc, something he mentioned earlier, saying that he would consider using different discount factors for different benefits. And I was wondering whether it's something that you found in the literature or something that you were putting on the table for discussion purposes.
Oh, that's sorry, I cannot put my camera onto the screen. I don't know why, but it's like this. But it's not something I've seen in the literature. This is something I'm putting on the table, actually, because of the benefits being with various lasting effects. And, well, as you said, one ton of CO2 emitted today, that's not the same than in 20 years. But what about biodiversity? What about water quality? Maybe not the same. And or the same type of considerations for the benefits also. So this is only something that I'm putting on the table. Steve, I don't know if you have access to all the questions that were put by the audience in the Q&A. Because there are some of them.
I just see one of the attendees has raised their hand.
There are also questions, actually.
Okay. Andres, you can post, I assume you're wishing to ask a question. You can post a question in the Q&A tool. Otherwise, I can activate your mic if you're prepared to speak publicly. Okay, Andres, you have the mic. No? Okay, so just a reminder, if you do have a question, feel free to type it in the top of your toolbar. You should see a Q&A there. Michel, Lino, would you like to add something?
Mike, Michel.
No, it's just a comment. There is a word that has not been pronounced in this session, in this webinar. It's dam safety. And I would want to stress that dam safety is the primary condition for sustainability. And it has also the same economics aspects. A safe long-term living dam will cost more than a dam which is not so good, so well designed, and so on. So I think we, in this work, we have also to keep in mind this aspect. I think it's very important. At the moment, there are a lot of dam failure due to some climate change impacts, other organization of construction which is evolving, and I think that this subject of dam safety has to be in the background of the work of these committees. Yes, absolutely, this committee and all the process. That's my comment. Thank you.
Thank you for that, Michel. Luke, did you say there were some questions coming in from the
Yes.
email? Okay.
Yes, from the Q&A.
I don't see those on my screen.
Oh, let me try to publish all the conversations then. Oh, well,
I see raised hands.
I see raised hands, yeah. But...
okay.
Malcolm,
Okay, and meanwhile, I will try to sort out this question of publications of the...
Okay, Malcolm, would you like to take the mic if I activate your mic? Okay, so we can see raised hands, but there seems to be trouble with accessing if you're typing questions into the Q&A. I'm afraid I can't see. Oh, here we go. Okay, yeah.
Q&A is not set up for this meeting.
Yes, it is. It's now. I think, Steve, you should now have access.
Yes, perfect. Okay. Okay, so a question here for you, Marco. So with respect to your work in Technical Committee D and on Volume 3, the upcoming Volume 3, so as Marco presented, Volume 1 is complete, Volume 2 and 3 are now very much underway. It's recommended here to take a look at Section 8 of Bulletin 169, which has previously looked at measuring greenhouse gas emissions in impounded dam reservoirs. So I'm not sure, Marco, you mentioned volume in the work of Volume 1. Reservoirs are excluded from the analysis, but is that still the case for future volumes?
Essentially, it is still excluded also in the future volumes. So our interest from our committee's point of view is really in the dam construction itself and the around, let's say, the dam body. If looking at the Volume 3 and looking at the whole life cycle of the concrete dam, the aspects of rehab, refurbishment works and stuff like that. So essentially the aging aspect is coming in. And I think where it really becomes very interesting is in terms of the end of life scenarios. This is very difficult to handle, to grab, because there are quite a number of options. And possibly if we look at dams, concrete dams, for example, or let's say in a general sense, like other concrete type or cemented material dams, which are close to urban centers, this circularity and recycling aspect becomes quite interesting, because then it would be possible economically to use rubble material from urban centers and vice versa. I can, if I'm deciding to decommission a dam and like break it up at least partially or so, then I can use this material in construction work in urban centers for building and so on. And the carbon capturing aspect of this concrete rubble is super interesting because it absorbs CO2 if I'm breaking up this old concrete, which is not carbonized yet. So it has interesting aspects, but this is all without the reservoir, because this is clearly outside our terms of reference and our expertise in our committee.
Okay, thanks for that, Marco. Luke, there's a question here for you, where the terms of reference for E&S impact assessments usually require comparisons of alternatives in terms of dam location and operating water levels. For the selected dam location and levels, there's no requirement to compare and justify that the selected type of dam is actually the most suitable. The criteria for selecting the type of dam is finally driven only by cost, unless the regulations on financing institutions evolve and require the demonstration that the dam type is the less impacting. What do you think about that possible evolution? So at the moment, the gentleman or the lady is saying that there's no requirement in the E&S analysis to pick a dam type, but as Marco and others have alluded to, different dams will have different carbon footprints, and even a particular dam type can reduce its carbon footprint through certain measures.
Well, I'm not sure it's not imposed by all regulations. In many countries, there is a need to compare all options, including, I would say, the technical options also. But by the way, I hope, and I think this could be an outcome of our work, of our works. I hope that it will be in the future common practice to also compare the technical options for a selected dam site.
Okay, good. Okay, we have another question here. Looking at the discount rate, so this is a question for Lamis. Since we're planning infrastructure for 50 or 100 years, a useful lifetime, does the idea of a 0% discount rate or even a negative discount rate have any traction? So that would be to, when you're looking so far into the distance, any costs are effectively zero if you bring them back to net present value. So if having a much smaller discount rate would make us more incentivized to consider the costs further down the line. So Lamis, what are your thoughts on that?
Well, actually, there was a proposed methodology by the World Bank, I think it was, put for comments around 2015, 2016, which was looking into that, saying we should pay today to preserve the environment for tomorrow, which means that we should put a higher weight on tomorrow than today, which is like having a negative discount factor, zero discount factor, or what they ended up proposing was a lower discount factor for projects that have favorable impacts on the environment. And so they put that for discussion, and then we never heard back of it, which means that the general consensus was that this was not a very good idea. And if you go back to the general framework, we don't have a lot of money right now, right? We have limited resources. So the question is always, where should I put these resources? And so if you say for some projects, I'm going to give negative weights to costs that we have today, you are going to divert the resources to those projects you decide on, and not necessarily evaluate all infrastructure or all investment opportunities in a comparable manner. And if you apply that same logic to greenhouse gas emissions, it will mean that you will accept to emit a lot of emissions today to be able to save less in the future. And as our understanding of climate models right now says, this is really a bad idea. If the little emissions today equals a lot of emissions tomorrow, so the nature discounts in some way. I'm not a good climate scientist, but nature discounts, which means that if we save CO2 today, we will have the opportunity of consume or of emitting more CO2 tomorrow because of those feedback loops I was talking about earlier. So to answer shortly, it was considered, it was put on the table, there was quite serious work behind it, and then at the end of the day, it was not selected.
Okay, thank you. The whole topic of time and discounting is huge, and there's, as Lamis says, there's a lot of publications talking about what the correct discount rate is. I'd recommend actually one book, Time, Discounting and Value, which is a whole series of work on just the discount rate and whether there should be a social discount rate, or as the question was asked, whether it should be a zero discount rate, looking so far into the future. Okay, there's a couple of questions here asking about the recording and access to the presentations, and my understanding is, Luke can clarify, but my understanding is they will be available within the members area of the ICOLD website in due course.
Yes, this is exactly what we proposed, that the recording would be made available to ICOLD members. So through the ICOLD login into the website.
Okay. Okay, I can't see any additional questions there.
There is one from Andres Amaya who just posted it, the one who was raising his hand. Maybe you can see it if you refresh the.
Sure. Let's do that.
Can you see it?
No.
No, okay. His comment for Luke mentioned focus on costs and benefits. Lamis, on the other hand, mentioned the first question to pose would be if there is a social benefit net. Can you please comment why not consider benefits as a must? Ultimately, a project like this with no social benefit would be contradictory. That is Andres Amaya comment for Luke, I guess.
Oh, okay. This is both an easy and difficult question. Easy to answer because, of course, any project must have a social benefit to proceed. Now the difficult part of the answer is that yes, we would like to also address benefits, but this is very difficult, probably more difficult than to address costs. And we thought, maybe Francisco, you will elaborate on that. We thought that the first step for our group would be to do things that will improve sustainability in terms of what are the costs of our projects and how we can improve our projects so they are less costly in terms of sustainability. Of course, and 10 times, of course, we need to make them with more benefits. And Peter stressed on multi-purpose. Lamis also expressed ideas on relating to that. Yes, of course, there is also this part, but we believe it's beyond our capability.
Yes, and we have to start with something. I think this first webinar is a very important starting kickoff for this whole issue. And as we will be moving forward, receiving comments like this one, for example, this will shape our future work. And this is exactly what this is all about. So thank you very much for this comment as well. And we will try to involve as many of you as possible to help us, as I say, shaping this. So thank you very much. Okay, Steve, is there anything else or should we go to final remarks?
I think possibly final remarks. So my understanding is that if there are more questions, I think, Francisco, you'll be sending an email out where there'll be an opportunity again to, I see more questions coming in. So if you do have questions, please do respond to Francisco's email and those questions can be passed directly to the speakers. Before handing back to Luke and Francisco for some final words, I'd just like to thank each of the speakers for their time and their preparation today and in the days building up to this, as well as the delegates for joining from around the world. I know we have people. Peter himself is in Asia, and we have people from many time zones. So thank you for joining. And I found it very useful. I've certainly learnt a lot. And as I say, I will go back and revisit some of these presentations. I'm pleased to say that the main topics and the conclusions raised today are going to be published in the International Journal on Hydropower and Dams. So there'll be a short report where everyone can read a little more. And as Luke and Francisco already mentioned, keep an eye out in your inbox for an email linking to a recording of the entire presentation, the entire webinar, and also the opportunity there to post some follow-up questions. So now, just for some concluding remarks, back to you, Luke and Francisco. Thank you very much.
Okay. So let's conclude with this a couple of points we have pre-prepared for you, wrapping up all this webinar today. Dams and sustainability is a very important, sensitive, as we have seen, very complex topic, and as well very urgent.
As ICOLD members, we are all in this together.
Our future works must involve several technical committees, and it must be done in an organized way.
Also, we believe it is necessary to build on the work done by other organizations, and we will need the help of experts, and this must be organized.
At this stage, we still need to define precisely the purpose and the organization of our future work, as we were just commenting a moment ago.
For this, we need your active support. At the conclusion of this first webinar, we will share a questionnaire, which we hope to collect your thoughts and proposals, particularly in relation with the upcoming 3 webinars.
And our vision is most likely a working group will be set up involving representatives of the different technical committees that are interested and whose work is relevant to our common objective, as we have mentioned before. So let's have a focus meeting in Delhi and organizing ourselves in this group.
And along with Paco, many thanks to all the speakers for their time. Peter, Marco, Joachim, Lamis. Many thanks to Steve and Hello and DAMS for the support. Many thanks to you, audience, for your interest and present and future contribution.
Thank you, Luke, also to you for the organization and support. It has been a great experience up to now. Okay, so we have a final slide where we have this email. Look, we wanted to say if anybody wants to send also, in addition to the questionnaire, any comment or any feedback, can use also the email of our committee team. Thank you very much. Okay, so
thank you.
We conclude here the webinar. Thank you.
Thank you very much.
Thank you.
You both.
Thank you.
All right.
Thank you.